So recall the concept we learned earlier, right? What do we mean by descriptive statistics? It is simply the numeric value that describes your data set. You don't need to do any prediction, any sophisticated calculation, but simply to describe, right? Do we have a group of large numbers? Do we have a group of small numbers, right? Are students getting high score in the homework, or are students getting low score in the homework, right? Is everyone at the same level or all over the place, right? Or I have students who are really smart, doing really well, but I also have other students struggling, right? So it's a description. So we will learn the metric in two major areas. The first area is the measure of location, and the second area is measures of variability. What does that mean, right? So again, now we're doing the translation between statistics and plain English. So in statistics, when we talk about location, we're talking about on the horizontal axis, on the continuum, where the center of your data is. So remember what we saw last time when we look at the invoices, right? The invoices of the auto parts ranged from the 50s to 60s, 70s, 80s, 90s to over 100. On the horizontal axis, we have the small numbers on the left-hand side, but large numbers on the right-hand side. So when we say locations, we're asking, where is it on the continuum? Is it on the left-hand side, right, a lot of small numbers, or is it on the right-hand side, a lot of large numbers, or is it in the middle? So that's what we mean by location. A specific example is, like, again, here, homework 1 score, right? I just checked it. So if I look at like overall, right, the average or the majority of my class, I will see the majority of the class are in the low 90s. So relatively, right, from 0 to 100 in this scale, the low 90s, it is a pretty like high score. So I would say I have students getting pretty high score in homework. It's a pretty good class, right? That's the implication. So that's what we mean by measure of location. It's a group of large numbers, right? High scores in homework. Variability, however, is a different story. So variability is asking how different these numbers are. Are all the numbers pretty much close, right? Or is everyone getting the same score? Or we have huge variation, huge differences. So again, think about the example we had from 2 weeks ago, the invoices. Some are as expensive as $109 or $105, but some are as inexpensive as $52, $57. And there's like $50, over $50 differences. No, it could be very expensive, it could be not expensive at all. You get to try your luck. And that's like huge variability in like auto parts invoices. And in teaching, I see the same. Actually, I think for my Tuesday class, Tuesday or Thursday, one of those, I think Tuesday class, when I checked the score, I was a little surprised. So the average was about the same. Average was also in the low 90s, about 91, 92. But I was surprised about the variability. So in that class, I had 2 students getting 100, but I also had 1 student getting 64 and another student only getting 70. I mean, the rest of them are mostly like 88 or 92, like in that range. And so like in the 80, 88, 92 range, I'm not too worried. And I think, okay, that's approximately right how well you perform. You understand most of these knowledge, maybe you are off in one or two questions. That's completely okay. But I mean, if you get a full point, that's perfect. That means you mastered every single detail. But if I have students struggling in the 60s or 70s, I mean, number one, that would concern me, right? They may have issues like continuing process to next chapters, but more importantly, then I'd be concerned that if I give the same example, right, would all my students understand? I mean, for sure, the 100 or the 92 students, I mean, they would get it. But for students who already struggled with the basic concepts, would they be able to capture that? Right, so if I have a huge variability, that may be an issue, right? I mean, again, it depends on the context, but in the context of teaching, it is a problem. In this class, like I said earlier, I'm pretty happy with the performance here because in this class, number one, you got pretty high score. The average is also in the 90s. And then number two, there isn't a huge variability. We got a few 100, we got a few 96. And I think even the low, yeah, like I said, there is 176. But other than that, everyone else is like above 80, like a few 84, 88, and then the rest are 90s. So that means, right, like almost everyone is in the A and the B range. That means we're all on the same page. If I give just standard regular examples, I probably can expect that everyone in this class to fully understand to be able to participate. So that creates a better situation for me to manage, right? So I'm just giving you some context on understanding what we're going to learn today. So location versus variability, those are the two typical metrics we use to describe our data. It's all about descriptive statistics, just to help other people understand how the data look like, right? How students perform in my class. Do they do well? Do they not do well? Are they about the same? Are they very different? So that's what we're trying to do. And as we dive in that, almost as a review of what we learned in the earlier chapter, think about the difference between population and the sample. We learned that the population means every single data point, right? Everything, not missing a number. But the sample is a subset of the population. Right? For whatever reason, if we don't have the time, we don't have the resource to study the population, we just gather information from a limited set and we study the small set. That's a sample. We've learned that. So the new term we learned in this chapter is when we describe our data, right? When we calculate those descriptive statistics, if the descriptive statistic is computed from a sample, it is called a sample statistic. But if we do the calculation from the population, like all the numbers without missing anything, even though it's the same calculation, right? Calculate the average, it's the same calculation. But if we do it for the population, that number will be called population parameter. So population parameter versus sample statistic. One you calculated for the population, the other you calculated for the sample. It is important in statistics to be precise. Because when you do reporting, you want your audience to understand, did you look at like thousands of numbers, or did you only study maybe 20, 30 numbers, right? Because if you only studied 20, 30 numbers out of thousands, then it means there is a chance that you missed some other information, right? Or in other words, your result will be slightly less reliable. I mean, just be practical. If you don't see everything, there's a chance you miss something, right? So your audience understand, yeah, there is a chance you miss something. This is less reliable if you got a sample statistic. But if you have a population parameter, that means you look at every single number in your data set. You are not missing anything. You are very confident and very precise about your analysis. So that's what you want to communicate. And again, we don't want to like write about 2 paragraphs on this is what I did. I'm doing this so well. The best way to show is just to indicate very clearly sample statistic is this, or population parameter is that. So people know where you calculate your number from. So that's all I'm trying to say here. Well, sample statistics certainly has a limitation. It is a point estimator for the population parameter. And like I said, we're doing translation here. What do we mean by an estimator? In plain English, we say, we will take a guess. So the estimator is the statistical language of taking a guess. If I can't see everything in the population, right? If I wanted to see how students do in statistics for all CBA students, we had thousands of students in School of Business. I honestly don't have time to analyze thousands of numbers. So I will miss the population. But what I have is my class, right? Here in this class, I'm supposed to have 18 students. So that's a sample, right? That's a small portion of all CBA students. When I look at how well you guys doing, okay, students are doing well. Chapter 1, well understood, they performed well in homework. So I can do the estimate, or right, I can take my educated guess and tell the dean, the chair, that I think students are doing well for the beginning of the statistics class. They probably all understand what we're trying to do here. Again, even though I'm not looking at thousands of students, even though I only had a small sample, I can make some inference. I can make my educated guess by just looking the sample. So that's what we mean by estimator. So the sample statistic is the point estimator for population parameter. In other words, if I calculate the homework average from this class, I can make a guess and say, oh, probably all business school students, they are like in the low 90s range for the knowledge in chapter 1. That's the estimator. I estimated the population parameter. I estimated population mean, right? The average of all CBA students will be in the low 90s. So those are the concepts. Sample statistic, population parameter versus point estimates. So now let's see what are the exact metrics we calculate. For measures of location, right? For the very first type of measures, we will talk about the mean, the median, the mode, the weighted mean. And we'll briefly go over geometric mean, percentile, and quartile. So again, the higher priorities are mean, median, mode, and weighted mean. The top 4 are what you want to understand very well, spend all your time on. The other 3, geometric mean, percentile, and quartile, we will go over briefly. you can find more information on the textbook, but to be practical for the scope of this class, this is the only week you will need this knowledge. After this week, we will not calculate any of these three till the end of the semester. So for the scope of this chapter, you need to understand and be able to calculate. But again, for later in this class, it's not as important. So you know where you want to spend more time, right? What you want to practice more. And we dive into each one. So the one that you are most familiar with is the mean. So the mean provides a measure of central location. It is the average. In plain English, we always say average. In statistics, we use the word the mean. They are referring to exactly the same thing, not a single point of difference. So it is the average of all data values. Typical example, like I said, we use on daily basis, right? I will tell you what's the mean of a homework score, right? What's the average homework score? Or we look at the weather and say, okay, what's the mean temperature in September? That means what's the average temperature in September? What's the mean distance from the university, right? Basically, I'm asking how far on average you live away from campus, right? And what's the mean of your driving distance? How many miles do you drive on average, right? So it is the concept that we actually use on a regular basis. But in plain English, we just keep saying the average. While in statistics, we use the word the mean. Why we need to know the difference? When you write reports, right, for professionals, or you read reports from other professionals, there's a chance that they use the word the mean instead of using the word average. So you just want to be able to understand. So pretty simple and straightforward concept. The one thing that may be new to you is notation. We talk about the difference in sample statistic and the population parameter. How do you communicate that to your audience, right? You just write a report and you want to keep it short and precise. In your report, you use the right notation. So for sample mean, right, or sample average, we use the notation of X bar. So you write an X and you draw a short line on top of it. This reads as X bar, meaning sample mean. For population means denoted as mu. So look at what I'm writing. So it's similar like writing an M, but your left leg is very long. You start with the left leg. You do like here, and then you draw the curve. So this is a Greek letter. It's not English letter M. It's Greek letter mu. So this denotes population. So you don't have to spell out in your answer in your report. You just write mu, and everyone in statistics will understand, oh, it means population. And similarly, X bar, you don't have to spell out sample mean or sample average. No, just write X bar, everyone understands. So make sure we understand that we can use the right notation. Oops. Yeah. So that's for the mean. In terms of calculation, we're probably familiar, right? If you want to calculate the average, you add all the numbers and divide it by how many numbers you have. So when we calculate the sample mean X bar, it equals the sum of all the values, right? Look at the sigma, meaning summation, divided by sample size, which is small n, versus in population mean calculation. Population mean mu equals summation of all the X values divided by population size. So population size is a capital N. So look at the difference. In sample size is a small n, but in population size is larger. So make sure you use the right notation when you write the formula. Do not mix. So that's what I want to emphasize. A quick simple example. If we want to look at apartment rent, we take a sample of 70 apartments. Well, there are more in the city, but we only have time to analyze 70. So it's a sample of 70 apartments, and we recorded their monthly rent. So when we made the phone call, the first apartment says, oh, we charge $545 a month. And then we call the second apartment. Second apartment says, oh, we charge $715 a month. And then the third one said $530 a month, right? So we made 70 phone calls, and those are the 70 numbers we collected. To calculate the mean, it is simply adding all 70 numbers together, then divided by sample size, which is 70. So we can then conclude the mean, right, or the average of apartment rent for those 70 apartments is $590.80. So that's for the concept of mean, which again is the same as average. So any questions here?
The only difference, I guess I would say, is the sample mean, we're saying out of 70, but the population, we don't have the information, but that could be 1,000 or something of that nature, right?
Correct. Yes, that's a very good point. Yeah, thank you for mentioning that. Here, we can only say this is a sample mean, right? This is the average for these 70 apartments. If we actually ask like thousands of apartments, it could be very different. And we really don't know that. And that's why sample mean is only an estimate for the population. So we can use this to take a guess, but you know the nature of the guess, right? You may guess it correctly, but you may guess it incorrectly. So there is a chance that the population mean be very different. So yes, that is true. The statistical analysis for the sample. So like I said, the sample statistic will serve as an estimator for the population. If our sample is taken randomly, right? I mean, I hope you read this from the textbook. If we randomly select the sample should represent the population very well, right? So it's like, okay, we survey the apartment in the more expensive area in the community, but also from the less expensive area, like, right? If we do that nicely, cover all different areas, then it should be a good reflection. It may not be exactly that same number, but it should be pretty close. However, there is a chance that the sample isn't selected randomly or properly, right? Like, just be realistic. If the researcher like simply doesn't want to drive too far to the other part of the city, or doesn't make phone call to those areas and only went to like close to where she lives, I mean, that may be biased. It may be like in the cheaper area of the city, but then you are missing out the more expensive apartments. Then your sample mean would be different from the population. So in an ideal world, we want the sample mean to be a good estimator or to be a good foundation for the population. And we make assumptions of that most of the time. The caveat is there is a chance that it's not a good reflection. That chance is relatively low. I mean, again, if the job is done correctly, right? If the sample is randomly selected, is a good representation of the population, it should be a good representation of the population. But again, if it's not done correctly, well, then it's going to be different. So it should apply to the population, but there's no guarantee. So Jason, does that answer your question? Yes, no? We good? Yes? Everyone? Any more questions? Yes, you're good. Okay, Brenda, good. Mikhail, good. Marcus, good. Okay, nice. Thank you. Yeah, good. Yeah, I mean, I really like this discussion. Just feel free to ask your questions, unmute yourself, or post in the chat window. Like, I will address all those. So yeah, thank you for participating in class. So that's a concept of mean. Another concept is median. So the median of a data set is the value in the middle when data items are arranged in ascending order. So that means in order to find the median, we first need to rearrange our data in ascending order. Because when you see how the data come in, right, we just make phone calls, go to their website, and we write down the numbers. Some are small numbers, large numbers, small numbers, right? They are all over the place. So to calculate the mean, there's no problem. But if the data looks like this, we can't find the median. In order to find the median, we need to rearrange them in ascending order. So that means in Excel, right, you just click sort from the smallest to the largest, and that should get you here. Like the smallest number, then the second smallest number, then so on and so forth until the largest number. So this is your starting point. And we want the middle value. What's the middle value? Well, if you have three numbers, right? First number, second number, third number. Obviously, the second number will be the middle number. If you have five numbers, first, second, third, fourth, fifth, the third number, right, will be the middle number. If you have four numbers, right, you count the two numbers, first, the second, or the fourth, the third. So your middle number will be the middle between the second and the third number. So you take an average of the middle number. So it's just physically where the number resides. You want to find the physical middle number, and that is your median. So in the apartment example, we have 70 numbers. So the middle will be in between the 35th number and the 36th number. So fortunately, those two numbers are the same. The 35th number is 575. The 36th number is also 575. So the average between those two numbers is 575. So that is the median of this 70 apartments. And when you just for fun, when you compare it with the mean, right? The mean is 590 and the median is 575. They are different, but they are actually pretty close, right? In the whole range of like the 500s to 700s, they are pretty close. There's only $15 difference, right? Given those hundreds of dollars you get to prepare. So this is a good reflection of later what we will say a normally distributed data set. Meaning your mean and the median are both good representation of where the center, where the majority of your number is. Like, don't worry about the extreme value. I mean, yeah, there are like really expensive, nice luxury apartment. Like, no, that's not what we want to consider. There are also like really cheap ones, but that's not in the best neighborhood. It's not safe. We don't want to consider that either, right? We want something in the middle, like good enough, safe and convenient, but not overly luxury or nice. So that's the central location we try to capture. So mean and the median are good measures of that. Looking at another quick example, just on how we find the median. So here I got data from a yoga class. Small yoga class, 7 students. And I'm like, okay, how old are you? So we take data on how old the age from all the students in that yoga class. The first student is 26 years old. Second student is 18 years old. The third student is 27 years old, blah, blah. So we recorded their age. How do we find the median? We first need to arrange them in ascending order. So here we got the youngest, like a 12-year-old. Then the second youngest, a 14-year-old, and then the 18-year-old, 19, 26, 27, 27. So that's in ascending order. With 7 numbers, the middle number, right? The absolute middle, you count 1, 2, 3, 4. So that middle number is 19. So 19 is the median age of that yoga class. It's pretty simple. It doesn't even involve calculation, right? You don't add numbers, you don't subtract, you don't divide, you don't multiply. You just sort them and then find the middle number. It is actually pretty simple to find the median. What if we had a new student? Okay, now we had an 8th student. 8th student is a 30-year-old. Okay, so it's at the end of the ascending order. And now with 8 observations, the middle value will be in between the 4th and the 5th number. So we take the average between 19 and 26. So the median of these 8 students becomes 22.5. So that's how we find the median. A few things I want to point out though is when data set has extreme values, the median is actually a preferred measure of central location, right? So again, we're trying to find where the center, where the majority of the data lies, not the extreme values. So if you have extreme value in your data set, the best way to ignore those extreme values or not to let it impact your analysis is to use median to measure central location instead of using the mean. For that reason, the median is a measure of annual income or property value. If you are curious, right now, open Google and Google just annual income, annual household income, or annual individual income, or like property value in whichever city you live at, or you can also search for the state. When you Google that, you will see most, like 90% of the reports of the news that comes up are all showing you median income or median property value. Rarely, maybe 10%. Rarely any report shows you the mean income or the mean property value. Why is that? Because in income or property value, or a lot of other contexts, we have extreme values. So for example, looking around in the neighborhood, one person makes 40,000 a year, another neighbor makes 45,000 a year, another neighbor makes 50,000 a year, another one 48,000 a year, another one 42,500 a year, right? So looking around the neighborhood, okay, most of my neighbors individual making somewhere between, yeah, just Googled, good, yeah, so see, there's fine in class. Right. So if I look at the neighborhood, I will see, well, most of my neighbors, right, make somewhere between 40 to 50,000. I mean, depending on which neighborhood you live at. I mean, I know there are more expensive neighborhoods, and I know there are less expensive. I'm just giving an example. So if I look at most of my neighbors are somewhere between 40,000 to 50,000, right? So I should be concluding that on average or overall, right, this community, this neighborhood, people makes about 40 to 50,000 a year. So that should come from median. Why not the mean? Because let's say at the end of the street, there's one family, one person is a millionaire. Right? He also a huge business, like a huge company with hundreds of employees. If we have that 1 millionaire rich neighbor, and when we calculate the average, that 1 millionaire is going to inflate all our values, right? You think you add, okay, 50,000, 40,000, 45,000, 42,000, blah, blah, and a million. When you add those and let's say divided by 5 people, right? Or divided by however many people, that millionaire is going to hugely inflate the average. Like after you add that millionaire, right, his income, your average would be, oh, on average, people make 200,000 a year. And people make $250,000 a year. Which isn't true. Like, no, most of my neighbor, right, the majority in our neighborhood, we make like somewhere 40, 50, like 45,000 a year. That's a right representation of this community. Like that millionaire is one, what we call outlier. That extreme value inflated the mean. And so the mean isn't a good representation of the neighborhood. But if we use median, right, we just know, okay, there's one large number, right? Here, like here, right? If we look at the median, let's say if this is a huge number, if this is 3,000, right? If this is a huge number, it doesn't matter. Like our median doesn't change. We just know, okay, there's a very large number in our data set, but it's not affecting the median. We still look at the middle value after we rearrange it. So like having a millionaire in the neighborhood doesn't affect the median, but it is affecting the mean. And that is why when you Google it, right, most of the reports report the median, not the mean. Because in almost every neighborhood, every city, you have like 1 or 2 million near or even billion that skews your mean. And when that's skewed, again, it's just not a good representation of the majority of people living in that area. Now, if you say, oh, everyone is making 200 or 200,000 or a quarter million, then like tax rate will change, and then we lose all sorts of like assistance program. But no, that's not the case. Like the majority of people don't make that. A lot of people still needs assistance, needs all sorts of program. Like we don't deserve like really high tax rate, right? So you see, this is how statistics is being used, and this is how important choosing the right statistic in your analysis. Now, if you choose the wrong statistic, if you choose the mean, well, then your policy changes. It's going to have huge impact to the population here. So does that make sense? The difference between the mean and the median, and when to use the median. Does it make sense? Yes? Yes, no? Or do you have questions? Good. Melissa, good. Mikhail, good. Any questions? No? Victoria, good. Nice. Nice. Okay, good. Yeah, if we don't have questions, then I'll just move on. So that's huge difference. And there will be questions asking you like, what is the difference between the mean and the median? When do you use median, or what's the advantage of using median instead of the mean? So just know that we have that covered. It is on the lecture notes, and you can also find the language from the textbook. So that's the two like most important measures. The other measure is mode. Mode is also a simple concept. It doesn't require any calculation. The mode of a data set is the value that occurs with the greatest frequency. So it's just simply which number shows up the most time. It's that simple. You don't even need to rearrange. Like you don't need to add, subtract, no calculation, and not even sorting, rearranging. You just see which number comes up with the highest frequency. Sometimes you have one value showing up with the highest frequency. Sometimes you have exactly two numbers with the highest frequency. Sometimes you have more than two modes or two numbers showing up with the highest frequency. Those are all okay. You just report that, right? Because this is descriptive statistics. You just describe what are the highest frequencies. Going back to the apartment rent example, I mean, since we've already sorted it, we see there's $525 showed up one time. $530 showed up two times. 535 showed up 1, 2, 3, 4, 5 times. All right, so we check each value, and after checking all 70 numbers, we realize that the number $550, this number showed up the most time with the highest frequency, 7 times. So that is our mode. Our mode is 550. So it's just again another measure, another metric to describe the data. I will show you one summary slide on the relationship between the two measures. So what you see, those three curves are typically what we call distribution. So if you recall the histogram we saw 2 weeks ago, right? It described about the same information. So the height of the bar in histogram and the height of the curve here are representing relative frequency. So if you see the curve to like the higher point of the curve, you know that value shows up with high frequency. But if you go like see the other area, like here, if the curve is pretty low, it means relatively low frequency. So it represents the same information as the histogram, those bar charts. So what are they? In an ideal world, we should or we want to have the distribution on the left chart. So it is a symmetric distribution. When it is symmetric, we have the mean, the median, and the mode all at the same value. So you see this one purple line in the center, they should overlap. Again, that happens in an ideal situation. Rarely happens. Usually when they are close enough, right? Like the example we just saw, like 575 versus 590, the mean and the median, they are pretty close, and that's already good. So if they are really close, yeah, we can say they are symmetric. But again, the perfect situation is they all equal to exactly the same number. So that's one distribution that's easiest for us to analyze. But in reality, we face other situations. In reality, we may have a negatively skewed distribution, or we may have a positively skewed distribution. So negatively skewed distribution, if you look at the curve, right? The curve is have high frequency or is very tall on the right-hand side. What's on the right-hand side? Remember, large values are on the right-hand side. So high frequency for large value, but it's very low on the left-hand side, meaning low frequency for small value. There are data that looks like that. Versus the other one, right? Look at the positively skewed distribution. Positively skewed distribution, you have your mode on the left-hand side, meaning some small value showed up with highest frequency. But your large value have low frequency. Then again, think about the income example. And in my neighborhood, most of the neighbors are like 40, 42,000, 50,000, 45,000, right? Like most of them are on the slightly lower range of the continuum. There are a few like well-paid like programmer or like middle managers. Yeah, maybe they are making like, I don't know, 80,000 or 90,000 a year, right? That they are here, but not too many of those. And then in the neighborhood, there may be like 1 million, right? That's toward the end. So that's a typical positively skewed distribution. Like an income distribution always looks like this. And property value distribution always or mostly looks like this. So that's for you to understand what type of variable may have what type of distribution, how they look like, right? Again, we're talking about descriptive statistics, how they look like, how do you describe those? So we'll talk about the positively skewed variables. Who has an example on negatively skewed distribution? What variable may have this shape? Have a lot of large value, but very few small values?
Our class?
The homework.
Yeah, the homework. Yeah, the homework assignment.
Yeah, very nice. Yeah. Homework one score for our class, right? We have a few like 100, and we have a lot of people getting 96, 92, 88. So that's a large portion. So a lot of high values. I think there's like a couple of 80 and one like 76. So they're in the middle range. And then I think there's one student didn't turn in the homework. Well, that's a 0, right? That's on the left extreme. So yes, that's a negatively skewed distribution. Yeah, like I said, the one student who didn't turn in automatically gets a 0. So that's the end of the tail. Yeah, that's a good example. What other examples we have? Think about life expectancy, right? A lot of people live all the way until they're like 80s or even goes beyond, right? There are like 90-year-old or 100-year-old, but a lot of people in their 80s or high 80s. Some are in their 70s. I mean, those are normal, right? The majority. But there are people who suffer from certain disease or have like unhealthy habits. I mean, if they smoke or if they drink heavily, they may die at an earlier age, right? Some people die in their 50s or early 60s. So you see like a small portion in the middle. And then there are really unfortunate situations. I mean, even for kids, like if someone's like involved in traffic accident or really rare disease, their life ends at really early year. Right? Very few of them, but again, those happen. Right? So very low frequency for small values, like for young kids or people at early age. Few of them die at those age. A lot of people can live up to like 70s, 80s, but that's the distribution. My negatively skewed. Who can think about example on symmetric distribution? Not perfectly like the mean equals exactly the mode, the median, but approximately what data distributes like this. Like the mean, median, and the mode are pretty close. What data will look like that? Hey, yeah, that's a good example. In some societies, I wouldn't say all, but in a lot of societies, age distribution follows that. Now we have some like good middle age workforce, right? And yeah, we have young kids, and we also have like parents, right? They are older. So yes, age, that's a good example. A lot of societies have age distribution like relatively symmetric. Some society, like European countries or Japan, they have slightly more of the senior population. But yeah, that's only certain societies. But a lot of those, yes. Yeah, thank you, Jason, for the example. What other examples we can think about? Height, yes. Yeah, thank you, Marcus. Usually, right, if we look at like a society or a like large organization, usually the height is normally distributed. Now you have a large group of people in this average middle range, right? That's a majority. And in every society, every organization, yeah, you do have some tall people, but not too many, right? Your basketball players, a small group of tall people, and a small group of petite people. Yeah, I mean, not too many of those, but yes, they exist, but the majority are, yeah, somewhere in the middle. That's a very good example. Height. Also in a lot of societies, like weight also follows a symmetric distribution. I mean, people, right, we remain in this healthy, acceptable range, but there are some people like overweight or even like obese towards the other end, but there may be people like underweight. Yes, shoe size, yep. Similar to height and weight, right? The majority of people having the size in the middle of the continuum. Then you have larger feet and smaller feet. Yes, those are all very good examples. And also, in the context of this class, actually, like at the end of the semester, a lot of times I have this distribution for the final score of my classes. And yeah, usually we start simple, and in simple chapters, you see more people getting higher score. But naturally, when it gets harder, and the students, right, some of them have challenges getting the harder knowledge, or sometimes students get overwhelmed with other work. You will see the high score people will start to diminish. And then at the end of the semester, usually what happens is I end up with a large group of students in like low 80s or high 70s, like 83, 82, 80, 79, 78. That's like the majority of the class. So the majority will be in the B- C+ range. So high frequency there. And then I have some people doing slightly better. I have people in the like high 80s, but also some people like in the low 70s who struggle even more. So that's lower frequency. But for every single class, I have students who do really well. They are like high 80s, low 90s, mid 90s. Those are the A- students. And also, just to be really honest, every single class, I will have 1 or 2 students who get F or D, D- for whatever reason. But that's also a like typical distribution of the final score, like after all 16 weeks. I mean, for now on week 1, yeah, that's a negatively skewed distribution. But as we enter like later in the semester, you will see the curve start to shift. Like the peak of the curve will start to shift towards the left-hand side. And then usually by the end of the semester, it shifts in the center. Usually. And there are special cases, but most of the time we end up there. So any questions on mean, median, mode, the distribution of those? Are we good? Good, Marcus, good. Victoria, good. Nice, okay. Yeah, like I said, feel free to raise your hand, unmute yourself, or just type in the chat window. So, okay, good. Sharina, good. Melissa, good. Nice. Okay, perfect. Perfect, perfect. Thank you. Then let's move on to the next concept. This is also very, very important. A weighted mean. So in some situations, the mean, right, the average, is computed by giving each observation a weight that reflects its relative importance. The choice of weight will depend on the application or the context. But the weighted mean, this concept simply tells us not all the observations are equally important. Some are more important, some are less important. And we give them different weight based on the importance. Typical example, your GPA. So just curious, how many of you know how your GPA is calculated? Anyone? Or you don't know how to calculate, you have to pull out the report.
Isn't it the average grade of each class over all classes? Like then, let's say I'm taking 5 classes a semester and I get 3 Bs, 1 A, and a C. So we take those numbers and then divide it by 5, right?
Actually, no. So that's the simple average, right? So, I mean, what you are doing is this, right? You are calculating the unweighted mean. So, I mean, that is one mean calculation, but that's not your GPA. And that's exactly why a lot of students get confused. Like, I know, like a lot of students will come to me and ask, no, like I don't add them together, I don't get. So now let me show you exactly how to calculate your GPA and the implication of that. And this is why statistics is so important and practical. We really use that on a regular basis. So if you pull out Excel, yes, yeah, Melissa, very nice. Each class is worth a different amount of units, so it has different weight. That's exactly what GPA means. So GPA takes the weight of how many units it is, not just how many classes you are taking. So let's do this. Let's practice this together. If you have Excel, pull out Excel just for practice purpose, build this framework. We make one column of your grade, one column of your grade point, right? Is that a 4.0, 3.7, 3.3, or 3.0, right? The grade point. Another column indicating how many units, right? That's exactly what Melissa says. Each class is worth a different amount of units. I think this class is a 3-unit class, I think. But you have 4-unit classes, you have 2-unit classes, and there are 1-unit classes. So we need to build a column of weight. So start with these 3 columns. And then I will quickly show you. This is the formula to calculate your GPA, or formula to calculate the weighted mean. So the weighted mean, right, X bar equals the sum of W times X. So what's W? It's the weight times X is the value of that observation. So we need to first do multiplication. And then for the numerator, we take the sum of all that. The tricky part is the denominator. Previously, right, when we do the unweighted mean calculation, it's large n or small n, it's how many observations, right, or how many classes. But now when we do weighted, so this is the tricky part, the weighted mean, your denominator needs to be the sum of the weight. So in other words, when we calculate the GPA, this needs to be the sum of all the units you are taking. So was that Victoria? If you are taking 5 classes this semester, you need to see how many units each of them is and add them together. If, let's say, if 3 of your classes are 3-unit classes, one is a 2-unit class and another is a 4-unit class, then you will need to do 3 times 3 plus 2 plus 4. So that's going to be your denominator, not just 5 classes. And this is the tricky part. So that's a formula. And now going back to the Excel setup. So we will have a column of x times w. That's how we calculate the numerator. So for example, let me see. Are there any complicated variables to differentiate? That's a good question. So basically we're asking how to differentiate what is x and what is w, right? What do you use as the weight? So typically the weight will be represented as the relative importance. So it may be like time spent on something, right? It may be like units. It may be assigned, just assigned specifically, like on my syllabus, right? I told you class participation has a 10% weight, homework has a 30% weight, right? So it could be specifically defined. But overall, the weights represent how important each item is. So when you have an indicator of that, you know that's W. And what's X? If you get to calculate the average, right, or the weighted average of something, that something is the X. So for example, here we're trying to calculate your weighted grade point, right? The weighted average of grade point. So your grade point will be the X. If I'm calculating the weighted, let's say, weighted mean salary of all the hourly workers, right? Weighted mean salary, that means the salary will be the X. So it depends on the context. Usually when you say, I want to calculate the weighted mean of something, that something is the X. And then the indicator of how important each element is will be your weight. So does that make sense? Okay, good. Good. Yeah, just ask questions like that. Unmute yourself or type in the chat window. Yeah, I like this interaction. So once we build this, right, just for example, if you are only taking 2 classes for simplicity, you are taking a 4-unit class and a 2-unit class. So we type unit 4 and 2. So type this here. And then let's assume you get a B in the 4-unit class, right? So your grade is B, and then the corresponding grade point would be 3.0, right? So you type that. And then assume that you get an A in the 2-unit class, right? Type A in your grade. And obviously that's 4.0 grade point. So you type it here. So these are your input. Column A, B, and C are your inputs. And then column D starts the calculation. So remember, we get to do X times W. So in column D, you type equals, then B2 times C2. Hit enter. Excel does the calculation for you. So 3 times 4 is 12. Then for your second class, 4 times 2 is 8. So that's X times W. Then remember, we need to take the sum of X times W. So this is the formula. equals sum, and then in parentheses, you select the value you want to add together. I mean, here we only have two numbers. So that's your numerator. And then the tricky part is denominator, right? Denominator is not how many classes you are taking. Denominator is how many units they add up to. So you take the sum of the units. And once you are done with the two sum, then we will do the final step, the division. The sum of x times w divided by the sum of w. And now you see your GPA is actually 3.33. So even though you have a 4.0, you have a 3.0, your GPA isn't a 3.5. And it is because of the weight. You didn't do well in the more important class, right? The 4-unit class, that's more important, but you didn't do well. You did, even though you did well in the 2-unit class, but because it's less important, it has a smaller weight, right? Only has 2. That's why this weighted average takes more weight of your B than like less weight for your A, so you end up less than 3.5. So does that make sense? Karina now understand?
Yes, thank you.
Sure, good. Melissa got it. Karina got it. Good. So, okay, Victoria, nice. Oh yeah, yes, Marcus, can we show the difference that what we would get if we use a simple? Yes. So, if we use a simple method, if we don't consider the weight, right? Just look at, okay, you got 3.0 in one class and 4.0 in the other class. What you can do is equals, right? I mean, there is an Excel formula. Yes, 3.5. So there was an Excel formula that you can type average, parentheses, select your two values, close parentheses, hit enter. So that is your simple average. How do we get there? We actually take the sum of these two numbers and divide it by 2, because only 2 numbers, so small n is 2. So either way, you can do sum divided by 2, or you can do average. So that's how we get there. But I wanted to show you one interesting experiment. Let's say, what if you flip your A and B, right? What if you get an A in your 4-unit class and get a B in the 2-unit class? So what's going to happen here?
Your weighted average goes up.
Yes. If we get an A in the 4-unit class, right, the 4.0 takes on more weight, even though you only get 3.0 in the 2-unit class, your GPA goes up a lot. It suddenly reached beyond the 3.5, right? Now it's 3.67. So it does make a difference. What's the implication? Right? I'm telling you, statistics helping us making better decisions and do better just in daily life. So the implication here is, as a student, right, if you want to have a higher GPA and you have overwhelmingly so many classes to manage, where you want to spend more time and really focus and do well are the classes with higher units. Like in all your 4-unit classes, 3-unit classes, because now you understand that they carry more weight in your GPA calculation. So you want to spend more time and do really well in those 4-unit and 3-unit classes. Even if you like end up not doing so well in the 2-unit class or 1-unit class, it's still okay. I mean, of course, you want to do well in all the classes. I mean, that's for sure. But if you have limited time, it's okay to not do well, not to do perfectly in the 2-unit or 1-unit class. But you absolutely don't want to mess up your 4-unit or 3-unit class, just because they are more important and they carry more weight in your GPA calculation. So does that make sense? Yes? Good. Good, good. Okay, nice. And okay, makes sense. Good. Yeah, I hope this helped you like switch focus and do better in your own time management and GPA management. But I also wanted to show you another one very practical example. This one I actually want you to build in Excel and save it on your own desktop. I want you to have this like anytime you can access. Here, I'm building you a template on how to calculate your score for this class, this exact class. I told you on day one, there's no secret. There's no guessing, no gray area. If you get it, you get it. If you don't get it, you don't get it. Everyone is evaluated in the same manner. So now I want you to share with you the exact grade calculation template that I'm using for every single student. Everyone from here, everyone from my 8 o'clock class, from my Tuesday class, Thursday class, I evaluate everyone using the same template. So let's build that together. And when you have this template, like by yourself, you don't need to like wait until grade gets posted. You don't need to like guess or get anxious when you don't know it. You can calculate that anytime you want. So build in, again, the few columns. We need a column of the item that I account for. I need a column of what you actually get. Yeah, for now, we don't have midterm, we don't have final exam, but we started to have participation, we started to have homework. Right? So you need to have a column of what you get and have a column of the weight. So this comes from syllabus. Right? I told you participation was 10%, so that's 0.1. Homework was 30%, so that's 0.3. Each exam, because they are not cumulative, so each exam carries the same weight and they are all 0.2. So when you add these together, your sum would be 100%, right? The sum of 1 you can see in the bottom of Excel. So that's where this 100% comes from. For now, don't worry about actual credit. Let's assume for a typical student, right? Typical student, I would expect him to come to class all the time, right? So I would expect the student to get 100% or 100 in participation. So that's the very first input. Homework average, if you see on Canvas, you would see that we have 10 homework assignments total for the whole semester. So this score would be the average of the 10 scores you get throughout the semester. For now, if you only have homework 1, right, that's just that average, that homework 1 score. Next week, when you have homework 1 and 2, it's going to be the average of those 2. Then the next week, when you have homework 1, 2, and 3, it's going to be the average of the 3 numbers. But at the end of the semester, you should have 10 numbers, and that's the average of the 10 numbers. just for practice purpose, we type in 10 numbers, right? Just for any typical student. Yeah, sometimes he does better, like 90 or 85. There are harder chapters, or he simply doesn't have time to do it, like 70, 75, 65. Those are reasonable. So if those are the 10 numbers, the average will be like this. Right? So that's your second input. And then once you take the exam, you will know immediately what you get. But just for practice purpose, let's assume you get 85 in exam 1, you get 90 in exam 2, and you get 80 in final. So you got all the scores. And how I calculate your total would be, remember X times W, right? The weight is obviously the W. X is your score because I wanted to calculate your weighted score, right? So score is X. So X times W for each row. So for row 2, B2 times C2. For the next row, B3 times C3. The next row, B4 times C4, right? And then B5 times C5, B6 times C6. So we do all that, and then see, I'm just adding everything together. It's the sum of these products. Again, assuming we don't have extra credit, this is the weighted total. So yeah, even though like you do really well in participation, like you do really well in midterm 2, if you don't do well in homework or you don't do well in final, it's like it's not going to bring you all the way to A. You will get somewhere like a solid B. I mean, again, that's typical, a solid B. And then we talk about extra credit. So if you take extra credit, and let's say you get 90. And for now, I designed to give you another 3%. So that's 0.03. So again, X times W, right? I add that to what you already get. And now you raise from a B to a B plus, right? You raised from 84 all the way to 87, and 87 is a B plus. So that's the impact of extra credit. I know some students ask, well, what if I don't do well in extra credit? Right? It's another exam. There's no guarantee I get 90. What if I only get 50 in extra credit? Well, that's a fair question. If you only get 50 out of 100, your final score is still increased, right? If you don't do extra credit at all, your final score is 84. But even if you only get 50 out of 100, look at the calculation. It's purely addition. Whatever you get is added to your total. So we're not adding any negative number, right? We're adding a positive number. No matter how small it is a positive number added to your total. So even if you only get a 50, you are still raised by like 2 points. You went from 84 now to 86. You are at the higher end of a C. And then again, if you do better, you raise to B plus. So does that make sense? Like how extra credit affects your final score and how everything is compiled together?
Professor.
Hmm?
Yeah, it makes sense. I had a question. Are you recording these lectures just so maybe we can learn how to use
Oh,
Excel like on our own free time?
Good question. I think I mentioned on day one, so I'm not recording this exact lecture because because I'm using my own computer. The school doesn't give me a computer, and my own computer is very slow. If I record, it has like lagged and glitch, and I have problem lecturing. So what I'm using is on Canvas. I have recording from last year. That's what we can see. But if you want this, if you want this exact file, we're doing it now step by step. And if you still cannot follow, feel free to like email me. We can arrange, like in my office hour, where we arrange a meeting to make sure you build it for yourself. Like you can save it on your C drive or wherever you. So, like, it's not recorded, but I do want to make sure that you have everything. The recording from last year covers the same topic and like 90% the same examples I'm using this semester. Oh yeah, thank you. Thank you, Jason. So yeah, like I'm leaving my screen here, like for you to copy the exact design and the exact calculation. Is that okay?
Yes, Professor. Thank you.
Sure. Yeah. Yeah, so just make sure like we build the two columns, the score and the weight. So that's the X and the W. X times W, X times W for every item, and then we add them together. That's the weighted total, or like weighted average, or your total score for this class. So that's one thing. I mean, the purpose of showing you this is to help you understand how your own score is calculated, so you can manage it, right? If you get a lower score on one end, what's the impact to your final score? So you know that, and hopefully at the end of the semester, it doesn't come as a surprise to any of you. So that's one. And two, I also wanted to show you really quick, what if you don't do well in one component, right? And again, that's just typical what's going to happen. And there's no guarantee that we do perfect for the entire 17 weeks, right? If we do, yeah, that's great. But I mean, I totally understand. You got other classes, you got your family, you got your job. I understand. There may be 1 or 2 weeks that you simply don't have the time to take care of this class. I understand. So let's see, again, we're going to experiment together. If you don't do well in one item, how big is the impact? So for example, if you don't do well in one homework, let's say homework 3, couple of weeks from now, if your work suddenly got busy, you get to work overtime for the entire week, and you got family emergency and you're not feeling, or like if everything all got together, or you simply hit the wrong button, you hit submit before you actually complete everything. Okay, assuming you are not getting 85, if you only get a 50, what's the impact? Look at here. So again, when it was 85, your homework average was 78, and your weighted average was 87. But if you don't do well, if you get a 50, right, you fail that one homework, your homework average drops a little bit. It drops to 74.5 instead of 78. But because it's only one component among these many, right, and it's only 30%, So the total, like the ultimate impact to your final grade isn't huge. You see, you dropped from 87 to 86, but right, and it's a 35-point change in one homework. But even if it's 35 points, when it reflects to your final, it's 1 point. You see, right? Changing from 85 to 50, your final changing from 87 to 86. Yes, it's a drop, but you only lose 1 point. So the takeaway here is you can afford to mess up one homework. Is that clear?
So column E is the grades on your homework assignments.
Yes. Yeah. Column E is individual homework assignments.
How did you get it to become an average and it affect the homework?
Good question. So look at the B3. So B3 is the average of all 10 homework assignments. So here you type in the formula equals average, and then select all 10 numbers, close parentheses, hit enter. It will calculate the mean or the average of all your homework assignments. So here, when you change one number, right, this number gets automatically updated. And then because this number, see, is part of the calculation for the weighted total. See, we have B3 times C3, right? That's the X times W. So the B3 times C3 is embedded in the final score calculation. So when this number changes, it naturally gets reflected in the weighted average.
Thank you.
Yeah, sure. Struggling more with Excel part of this. Jason, which part can I help you? You good? Okay. Yeah, let me show you again how homework average is calculated. So we have 10 homework assignments. That means you will get 10 numbers. So after you have 10 numbers, you will need to type in Excel equals average and then parentheses. Inside the parentheses, select all 10 numbers. So nothing is missing. And once you type it in Excel, right? See, it stays there. Then any change, see, any change in your raw score will automatically be reflected in what you have programmed. See, if we change a number here, it's automatically reflected. So that's the change of one homework assignment. Like I said, even if you mess up one, right? Even if you lose 35 points or you completely fail one homework, I don't want you to do that, but the impact to your final score is 1 point. It's affordable. So like I said, the takeaway is you can afford to mess up one or maybe even 2 homework assignments. So again, if you don't do well, don't panic. It's not going to kill you. You are not failing this class. You lose 1 or 2 points, but no, you're fine. You're not failing the class. So that's what if you mess up one homework, right? And now let's get to a more serious question. What if you mess up one exam? Well, first of all, exam does carry more weights, right? This one number carries 20%. So be prepared that the impact is going to be bigger. But again, can you afford right? Like, should you be withdraw this class if you don't do well in exam 1, or can you continue, right? Is there a chance for you to still pass this class? I typically get these questions throughout the semester. Like, students email me, oh, professor, I failed exam 1. Should I withdraw? Or can I continue, right? Or I fail, or I forget exam 2. Should I withdraw? Can I continue? Right? The typical questions you're going to face. So let's experiment with the same template, right? If everything's normal, you do your extra credit, blah, blah, you are 87. What if you mess up exam 1? Again, if you didn't get 85, if you get a 50, okay, that's a fail. But it's not too bad. See, if you were 85, you are like 87 as your final grade. I mean, that's a B plus, right? I mean, that's the lower edge of the B plus. But if you get a 50 instead of 85, right? If you mess up 35 points in one exam, you're still 80. And that's B minus. That's not even C range. That's still in the B range. So the impact is about like 6 points, 7 points. If you mess up one exam, and yes, there's a bigger impact in an exam compared to one homework. But again, you could afford, right? You get a lower score, but you're still in the B range, and that's not bad at all. See, right? Changing from 85 to a 50. Is that okay? Yes, giving you more confidence passing the class, I hope. Do we have any questions here?
Yeah, Professor, I think this is a really good tool that you're showing us just for like future for all our classes too. Just look at the syllabus, see the percentage and points that are available. So that's awesome. Thank you for sharing that. The one question, going back to the formula,
yeah,
when you look at X bar over the, I can't remember the names right now, but when you look at that equation, the weight and the observation, and you multiply that divided by the weight again, does that doesn't show that in in that particular Excel, correct?
Yes, that's an awesome question. Thank you for asking. So why I'm not dividing? So that's a good point. So your denominator, right? Denominator should be the sum of the weights, right? So the sum of the weights, if we calculate that, right, equals sum of the weights. The sum of weights is 1. So even if I embed that, right, even if I embed the calculation to divide by the sum of the weights, it's the same value. Because every number divided by 1 or 100%, right? This is really showing 100% of your grade. So divided by 1 or 100%, it equals the original number. So for simplicity, I did not type in that. But thank you for asking. That's a good question. Thank you. Other questions? And well, actually, that's a perfect question in terms of showing you how the extra credit works. You see, I built in extra credit to have 3%, right? But you see, when I calculate your weight total, I'm not including that 3%, meaning I'm not dividing that. So you get those 3% for free. See, So let me show you the experiment. What if I don't build it for free, right? So if I also add this 3%, if it's not free for you, see, it becomes a lower score. See, it changes from 80 now to like only 70 something. But if I not include that 3% in the denominator, right? Again, I'm giving you 3% for free. Now you are raised to 80. That's the whole point of actual credit. I'm giving you for free, 3%. You do the actual credit depending on how well you perform. You get some addition. So that 3 additional percent is not built in the division of the calculation. So it's free for you. Other questions? Now we're good. Okay, so this is the template. Like I said, I hope you are all able to capture this, the calculation, and then use it for the rest of the semester. Get your homework score, like do some estimation on what you get in each exam, and estimate for what you get for like later in the semester. Don't be caught in any surprise or things like that. So that's for weighted average. I do have a quick and simple exercise. Simple exercise to calculate the weighted hourly wage. If a home builder hired 5 workers, each of them charge differently per hour, and they work for different hours, which again meaning if someone works for more hours, that means that job or that person is more important than someone else who worked less than 200 hours, right? So the hours will be the weight. So if we are given this number, we are able to calculate, again, step by step, XW, X times W, the sum of X times W and the sum of W. We are able to calculate the weighted mean for the 5 workers. And we can calculate the unweighted or the simple mean. Just simply adding 5 numbers of X divided by 5. That's the unweighted. The 2 numbers are close, but slightly different. So this, I want you to practice and review on your own. Just because we spend a lot of time on the GPA and your grade calculation. So we're not having too much time for this exercise. It is on the slide. It is embedded on Canvas. So please, after class, do this calculation for yourself and then make sure you are able to calculate the weighted mean and the unweighted mean. So that's all for the measure of central locations. The other few concepts, like I said, are of less importance for the scope of this class, but you do want to know geometric mean, percentile, and quartiles. Geometric mean doesn't do any addition or division. Instead, it does multiplication and the nth root. When do we use that? We mostly use geometric mean in financial or growth rate in financial data, or in population growth in all the demographic data, or economic growth. So if you are in those subjects or those areas, you will see numerous of examples there. But if that's not your area of expertise, then do not worry about this. again, the examples formula is here, but for practical purpose, not an exercise for this class. Similarly, the concept of percentile and quartile. You may be familiar with the concept that if you make it to the top 10% of your cohort, you get this scholarship, right? What does that mean? How does that translate to percentile? If you make it to the top 10%, right? Meaning among the 100% of students, if we sort the score from the lowest, see if any finance majors. So if we sort from the smallest to the largest, there's only 10% of the students having a score higher than you. But then the rest, the 90%, will be equal to your score or lower than your score. So that's what we mean by top 10%. So knowing that 90% are lower than you or equal to you, then you will be at the 90th percentile. And similarly, if some other criteria requires you to be the top 30% in your cohort, then it means 100% minus 30%, then 70% of the students will be lower than or equal to your score. So you are at the 70th percentile. So that's what this concept is related to the real world context. There is calculation on how to find the exact number, but really because this is rarely used, so I only show the example here, and you will be able to find that in the textbook. But again, for practical purpose, usually we don't use that. And similar for quartile. Quartile, we just cut the 100% to be 25%, 50%, and 75th% for the first, the second, and third quartile. And by definition, the second quartile means the median, right? That means 50% of the data has smaller values and 50% has larger values. So that's those concepts. Sorry, let me read the chat. Will this variable, oh, okay, thank you for asking. Here, right, like the P's percentile. So the P is the notation for what percentile. So it's not strictly a variable. Yeah, it's just what percentile. It may be like 90th percentile. Yeah, okay, perfect. So that's percentile and the quartile. Julia, are you finance major or wanting to explain this?
Yeah, I'm a finance major.
Oh, okay, then I can spend a minute. Okay. Yeah, sorry, I was trying to save some time, but if you need it, I will explain. So geometric mean is calculated by finding the nth root of the product of n values. So a lot of time we use it in like financial growth, economic growth, or population growth. So this is the formula. So instead of doing x1 plus x2 plus x3 divided by n, now we're doing multiplication. And after we do multiplication, we raise it to nth root. So for example, if you have a product or a portfolio and you have 5 periods, right? Your portfolio starts with a negative return, but then end up with a positive return. Every year it performs differently. And if you wanted to calculate the geometric mean, right? Or on average, what's the growth rate of this portfolio? You will first need to translate that into growth factor. So for example, laptop died. No, glad that you are back. So for example, if you start with a negative return, right? So minus 6%, 100% minus 6% translates to 94%, right? That's how negative return works. If you are a negative 8%, then 100% minus this 8%, your growth factor will be 92%. But if you are positive, right, if you are 2% positive, then you are 102%. So first of all, convert your rate of return into growth factor. And then what we do is we multiply all the growth factor, right, compared relative to 100%. What's the growth factor? Okay, 94%, 92%, 96%, 102%, 105.4%. So multiply all your growth factor. And because those are 5 numbers, so after you multiply, now you get to take the 5th root of that multiplication. Then you end up with a 0.9775, which again is the growth factor, right? Because here you are multiplying and taking the 5th root of a growth factor. So your calculation is a growth factor. So that's 0.9775 or 97.8% growth factor, which is lower than 100%. So what you get to do is typically just use that minus 100%, right? Then you see, okay, it's actually a negative return. Usually, if it's less than 1 or less than 100%, it translates to a negative return. But if it's greater than 1 or greater than 100%, it will translate to a positive rate of return. So does that make sense?
Yeah, so rather than dividing, we're taking the 5th root because there's 5 periods.
Yes, yeah, exactly. Because those are 5 periods and we're multiplying 5 numbers. So
because
this is not adding, this is multiplying.
So because it's exponential growth, that's why we're using the opposite, which is the square root. Okay, got it.
Yes, yeah, exactly. Because you think when you have a portfolio, right, your next period, the return is built on top of this current period. So it's not adding, it's like with this, you grow this much. So it's like depending on all your prior period. That's why it's multiplication. Addition simply means, oh, they are all separate, just put them together. Addition doesn't have this contingency, but multiplication allows you, okay, this period, then that gets to the next period and then becomes the foundation for the next period. So multiplication builds in the contingency. Other questions? Well, yeah, yeah, we are losing money with this portfolio. It is negative rate of return. Yeah, no, don't buy this one. Okay, good. So those are all measures of those are all measures of the central location. Which is one type of description, but remember we also mentioned another type of description is variability, right? How different the numbers are. are students performing at the same level, or I have really high performing students and also some students struggling, right? So are we at the same level? That's a measure of variability. Yeah, apologies that we probably can't take a break today. I think I spent more time playing with Excel than I wanted. So we're already eating the break time. So bear with me, let's just push through so we can end hopefully on time. Sorry about that. But yeah, I plan to take a break now, but we don't have that time. Sorry. So continuing with measure of variability. A few metrics: range, interquartile range, variance, standard deviation, and coefficient of variation. So for the scope of this class, the most important two measures are variance and standard deviation. So again, practically, right, if you only have limited time, if you only have time to do certain practice, make sure you fully understand variance and standard deviation. So these two we're going to use throughout the semester, almost every week. The other three, range, interquartile range, coefficient of variation. For the scope of this class, we only use it this week. So I mean, you will see that in homework. You will see minimal in exam 1, but beyond that, I'm not going to use this in this class. So again, I'm just telling you what's more important and what's less important. You arrange your own time, so you know which concept you want to spend more time on. With that, let's start with the simplest concept. The simplest measure of variability is range. So the range of a data set is the difference between the largest and the smallest data value. So it's a simple subtraction. Remember, we've already sorted our data, right, from the largest to the smallest. So once we have it sorted, you say, okay, largest is $715 a month. Smallest value is $525 a month. So the range, right, is the difference between these two numbers. Range is $190. So depending on which apartment you choose, right, there's a chance that you may be able to save up to $190 if you choose the least expensive compared to the most expensive. So that's the story about range. Also similar concept if you compare to, you look at the invoices from 2 weeks ago, right? The highest invoice is $109, lowest invoice was $52. What's the range? If you do subtraction, the range is $57. Yeah, a huge variation. It may be very expensive, but maybe not so expensive. Hard to control. So this just gives you a sense of how different things are. It is the simplest measure, right? I mean, since we've sorted it, it just needs one-step calculation. The limitation, though, is it is very sensitive to the smallest and the largest number. So again, if you have some crazily expensive apartment, right? There's a new construction building luxury apartment, rent $3,000 a month, but that's going to skew your range. Even though like most of us were not looking at that, we're looking at what's reasonable and affordable. That has a range of approximately 190. So, and similarly, look at your neighborhood when everyone makes somewhere between 40,000 to 60,000, right? Yeah, there's a difference of like 20,000 per year. But like, don't look at that median year. If you look at that median year, the range would be like some crazy number. So the problem with range is if you get any extreme value, right? Get your median year, your luxury apartment, this number is going to be skewed. And that's not a good reflection of what you want to capture. So it's a problematic measure. And in order to fix that, people invented the second concept of interquartile range. So the interquartile range is the difference between the third quartile and the first quartile. So remember, third quartile is your 75th percentile, and the first quartile is obviously the 25th percentile. So that means you are not looking at the 25% the smallest value, and you are not looking at the 25% largest value. So not that millionaire, not that luxury apartment, right? They are the top expensive ones, and you are not looking at those. You are only looking at the middle 50%, starting from the 25th percent, ending at the 75th percent. What's the range? So it overcomes the sensitivity to extreme data value. I mean, here in the apartment example, we don't have any extreme crazy value, but still, if you only measure the interquartile range, you will see smaller range. The first quartile ends 545, and the third quartile is 625, and the difference between those two numbers are only 80. So it's a much smaller range. But again, this one, we simply don't have any extreme value. So range and interquartile range are both reasonable. So those are the two simplest measures. They are still a little limited because we're making our analysis just based on two numbers. If we want to be more confident about our analysis, we wanted to look at all the numbers, right? Not just two numbers, look at everything we have, either in the sample or in the population. We want to include all the values. So if we want to do that, we will need to use the metric variance and the standard deviation. So the variance is a measure of the variability that utilizes all the data, not missing a single data point we have. It is based on the difference between the value of each observation and the mean, because we can calculate the mean for the sample and we can calculate the mean for the population. So we simply map each individual value to the mean. Now, okay, the average homework 1 score is a 92. The first student got 96. Okay, she's 4 points higher than the mean. Second student got 88. Oh, he's 4 points lower than the mean. Third student was 92. Okay, he got exactly on the mean, right? 0 deviation. So we map every data point to the mean. So we make the mean to be the standard, and then see how much each data value deviates from that standard. Maybe deviating on the higher end, maybe deviating on the lower end, but we just wanted to see how much they deviate. So the exact concept or the exact calculation, is here. You don't need to memorize. This is based on understanding. And once you understand, the calculation comes naturally. So read through. The variance is the average of the squared deviations between each data point and the mean. So you see, it specifies the few steps. When you read it, you see the variance is the average, right? Keyword is average. When you read here, you know, oh, okay, I need to do some sort of summation and then division, right? See this general form of calculation. You add a bunch of things together and divide it by population size. That's how you calculate the average, right? So, okay, I know I need to calculate the average, but the average of what? The average of the squared deviation. Keyword is squared. Now I know, okay, in my calculation, somewhere I need to do a square. But it's not straightforward. So then see in the calculation, there is a square. Square of what? Squared deviation between each data point and the mean. This is exactly what I said, right? Map each person to the mean. So that's why we're doing xi minus mu, right? Mu is the standard, and we see how far x is away from the mean. Is that 4 points, 8 points, 0 points, or 4 points on the other side? That's the deviation. So if you reverse engineer, right? Reverse engineering the whole process, you need to first calculate the mean. Once you have the mean, then you can calculate the deviation. Once you have the deviation, you can do the square. And after you square the deviation, you calculate the mean. That's the 4-step calculation for variance. Same operation for population and for sample, but I want you to pay attention to the notation. Population variance is denoted as sigma squared. So this is a Greek letter. Let me write it for you. Start from the center, right like this. So it's almost as you writing a 6, but when you write a 6, you point up. That's your 6. But sigma, you point flat to your right-hand side. Let's see, point to your right-hand side. So this is the Greek letter sigma. So sigma squared is population variance. Without the square, sigma is standard deviation. So that's the notation. That's for population. Sample variance is English letter. It's S squared. It's a small s, not a capital S. It's S squared, meaning sample variance. So make sure you use the right notation, right? Population, we use population mean. Sample, we use sample mean. There is a small difference in operation when you look at the denominator. When we calculate the population variance, we divide it by population size, and that's capital N, very straightforward. When we do that for the sample, this is not a small n, it's a small n minus 1. So we divide by sample size minus 1. Why we do that? The statistical reason behind is because we estimated the mean using sample data. We're not calculating population. So there's this layer of estimation / guess, and through that we lost 1 degree of freedom. And that loss of 1 degree of freedom is reflected as n minus 1. So that's the statistical reason. We have not learned that. So I do not expect you to understand it. Not a problem. What I do want you to know is just to remember, when you calculate the sample variance, it needs to be n-1. You need to know this. For now, you don't need to know the reason behind. Later in the semester, we will learn that. But as of today, we haven't. So don't worry about degrees of freedom losing 1 degree. Nah, that's fine. But just know it's n-1. So that's the calculation. That's for variance. Standard deviation is one step beyond. Standard deviation is the positive square root of the variance. So sigma square root get you to sigma, s square root get you s. So that's standard deviation for population for sample. Why is that? In statistics, it has pretty good logic. When you calculate the variance, right, look at this whole calculation. We have squared the deviation. Look at this, square. We have raised the deviation to the next power. So we actually have inflated the deviation. If we want to standardize it, now to inflate, right? Standard deviation, meaning standardize the difference. So if we want to standardize, we need to drop it back to the same magnitude. So after we raise it to second power, then naturally we should take the square root. So standard deviation puts the deviation into the same unit as the original data. So it's not inflated. The reason why we want to inflate at the beginning is for positive and negative deviations, we don't want the numbers to cancel out. We still want to account for the difference. That's why we have to square. But ultimately, we want to standardize it, and that's the square root. So any questions so far? What is variance and what is standard deviation?
So like if it was for grades, if you want to standardize the deviation, and for example, you get like a 0.5, it would mean that it's like a 0.5 out of 100%, for example.
Yes.
It puts it into context, right, of
Yes.
what you're doing.
Yeah,
and
exactly.
And then for variance, you get a, for example, 0.26. It would be 0.26 like out of 100%, and just the total data, like all of it, or how would that work? Or we're just doing it just to get rid of the negative?
We don't get rid of the negative. when there is the negative, here when you see the calculation, you see the square. So any negative value, when it's squared, it becomes a positive value. So we don't cancel that out. But to your question, how do we compare? We typically compare standard deviation because it's in the same magnitude, same unit as your original score, right? Your homework, that's the same magnitude. We typically don't like to compare variance because it's inflated, right? Because we squared it. And it doesn't make the perfect sense when you square your score, right? So usually we don't directly compare variance. We like to compare standard deviation. And when we do the comparison, after these two concepts, we will learn coefficient of variation. That's the most standardized way to compare the deviation. So we actually standardize that to the mean, not necessarily the total, but to the mean, and see relatively how much the variability there is. Other questions? No? No question? Good. Okay, nice. Now let's look at one example. To make it manageable, I just give you 4 numbers. Let's say new student chose his apartment, and now he is like, I need a refrigerator in my apartment. So he went to Best Buy and like all other stores in this area. But there are really nice refrigerators. There are old, used, refurbished ones, right? So he saw a total of like 30 refrigerators in his tour. But after some consideration, he made his short list of 4. So one is $2,398. It's a bit pricey, and he really likes it. Okay, it's on his list. Next one, $1,844. The next one is $1,539. And the next one is like a used but still decent refrigerator, $1,311. So we got the 4 price value. And now the exercise is, let's do it step by step to calculate the variance and the standard deviation. So again, if you go to Excel, let's make it easier by using Excel. Type in the 4 numbers and we start from there together. Just these 4 numbers. Yeah. Okay. So once we got our 4 numbers, yeah, I just have been talking. I have been talking since 8 o'clock, so it's some hours for me. Once we got our 4 numbers, remember step 1 is to calculate the mean, right? So remember the formula equals average, and then in parentheses, select all 4 numbers. So we're familiar with that step. Now we see, okay, for the 4 refrigerators, right, the tiny sample of 4, the mean is $1,773. That's step 1, calculate the mean. Then remember step 2 is to calculate the deviation between each data point and the mean. So now we use the price of the first refrigerator minus the mean of 1773. So there's a deviation of $625 just for that number 1. What about the second one? Second one, we use the price $1,844 minus $1,773. So there's a smaller deviation of $71. And then we do it for the third refrigerator. Third one is cheaper, $1,539 minus the mean. And we see the third one is actually cheaper than the mean. And similarly, the last one is even cheaper. So we got the deviation, and you can see we have some positive deviation and some negative deviation. So don't touch the positive or negative sign, just keep them there. Then remember the next step. The next step is to square the deviation. So in Excel, when you square, you do equals, select the cell that you want to square, and then hold Shift and 6. Like, see that exponent sign, that raise it to the second power. Type 2, meaning raise to second power. That's how you square a number. So we have to do that for all the deviations. Let's see, first, second, third, fourth. So that's the deviation for all 4 numbers. And then, so that's step 3, right? Then we get to do the last step. The last step is the average of those squared deviation. And remember, for the sample, right, the denominator needs to be sample size minus 1. So we first of all get the numerator. That's the sum of those squared deviations. And then this sum divided by sample size minus 1. So 4 minus 1, denominator is 3. And we got our variance. So again, variance is an inflated number to measure the variability. So usually we don't like to interpret variance. We would like to calculate one more step, make it to the same magnitude, the same unit. So let's calculate standard deviation. So standard deviation, remember, is the square root of variance. So in Excel, we need to type equals SQRT, meaning square root. Then in parentheses, type in which cell your square root about. So put in that cell, close the parentheses, hit enter. So the $470, this is your standard deviation. Are we good? Yes. Karina, good. Julio, good. Christine, Victoria, nice. Nice. Okay. Yeah. Okay. Brenda is good. Okay. Nice. So this is how we calculate step by step for standard deviation. There is a shortcut. So the shortcut is there's an Excel formula. So you type equals VAR, meaning variance dot S, meaning for the sample. So equals VAR dot S is the formula for calculating sample variance. And then put in parentheses your 4 input values. So you get the same variance. So again, this is the formula, VAR dot S. And similarly, there is a formula to calculate the standard deviation. So type equals STDV dot S. So this is the formula for standard deviation for the sample. So STDEV means standard deviation. Dot S means for the sample. So now we select all 4 input data. Close parentheses. We get the same value, same as what we calculated earlier. So that's the Excel formula for standard deviation. I do not have a strong preference. You can do it either way. I mean, you can even calculate manually, right? Pull out your calculator, write down each number, or you can do the step-by-step calculation as we did together, or you can type this one-step formula to get to the final number you need without the intermediate steps. Whichever you feel comfortable with. I know some students like to see the step-by-step, but some students just want to get to the final number. Either way, as long as you get it right, I don't control how you get there. Any questions on this calculation? Are we good? Yes, Kristen good, Victoria good, Trina, Ken good, Melissa good, Marcus. Okay, good. Thank you, thank you. Yeah, I like to see feedback like this. Perfect. So we know how to calculate the variance and the standard deviation using Excel. I do have the same information on the slide. So later when you review it yourself, you can see it from here. And then, like I mentioned earlier, if we really want to do comparison, right, how much variability there is, if we want to do comparison across, the new concept is called coefficient of variation. So it indicates how large the standard deviation is in relation to the mean. So that means relatively, right, given the level of the mean, is this a large standard deviation or is it a small standard deviation? If it's a large value, right, relatively if it's large, it means there's a lot of the variability in this data set. If relatively the coefficient of variation is small, then we can say there's not so much variances, there's not so much variability in the other data set. Mostly all the numbers are pretty close to each other, everyone's on the same page. So that's the interpretation. Calculation is also very straightforward, just using the standard deviation divided by the mean. For the population, for the sample, same calculation. Quick and simple example. We're not talking about a yoga class. If now the city opens 2 art classes, one art class is like in the city center close to the university, with like all the students, the faculty, staff, admin, like they all go there. Yeah, we look at, okay, the mean age of that class is 29 years old, and the standard deviation is 4.6. That's for class 1. For the second art class, it is open near the senior community center. So all the students are the senior residents. And we look at the mean age of that second class is 84 years old with a standard deviation of 10. And those are huge, like different age groups, right? The first age group is like a younger towards middle age, not even middle age. But the second class all have senior citizens. So how can we compare if there's large variability, large deviation? We calculate this is coefficient of variation. So we standardize that standard deviation to the mean. So after we do that, we see for the first class, the coefficient of variation is 15.86. But for the second class, it's only 11.9. So we can say that the first class population has more variability, or there's more variables, more differences in student age in the first class, while the second class population doesn't have so much difference in terms of student age. So that's what we can do with coefficient of variation. It's mostly used for comparison. If you don't want to compare, you don't need to calculate. Usually, like the standard deviation itself is a good measurement of variability. So that's the use of this matrix. If we go back to the 70 apartment example, later after class, if you do the practice, you calculate the variance, standard deviation, coefficient of variation. You can match it with what I have on the slide to make sure you get the right numbers. It's the same process as we described earlier. And finally, again, there is one example I'm leaving for yourself, for you to practice on your own. I mean, we've done a few examples together, but the key is I want you to be able to do that on your own. Before you dive into homework, right? Because in homework, if you get it wrong, you lose points. So before you dive into homework, do this one more practice. So here we only got 25 numbers. So the context is like towards New Year Eve, right? In holiday season, we see all those drunk driving check stations. So the police randomly checked the 25 drivers on their blood alcohol level. So here's the data, 25 numbers. And from the 25 numbers, can we calculate the mean and the standard deviation for them? And just for practice purpose, can we calculate the coefficient of variation? So if you were to practice this after class, which I don't want to keep you longer, so I'm quickly showing you the easiest way is to first input all 25 numbers in Excel. Don't worry about percentage. You can translate into percentage later after you do calculation, but just type the number. If it's 0%, you type 0. If it's 0.08%, you can just type 0.08. If it's 0.15%, you can type 0.15. Just leave the percentage outside your calculation. You can add it back later. So type the 25 numbers, and then what you can do is calculate the mean by using the average formula, and then calculate the standard deviation by using the standard deviation formula. And then finally, when you get to calculate the coefficient of variation, just do a division between the two numbers. So if you perform that, you should be getting this result. So on slide 44, I show you the correct answer for the mean, the standard deviation, and the coefficient of variation. So that's what I want you to practice and make sure you can get before you do your homework. Like I said, if you make a mistake in the homework, you are losing points. But before that, make sure you understand and you can do it. That's all the key concepts we have for chapter 3. Like I said at the beginning of the class, if you have not read chapter 3, it will be very, very helpful if you could read it after class. Then take another look at the lecture note, do the practice that I suggest you to do, and then do the homework. Make sure you submit the 2 files, the multiple choice and the fill in the blank, before next Friday. And again, ideally you want to do it sooner than later. Don't wait until you forget it. Try to do it later today or tomorrow when your memory is fresh. So take care of the homework. And then for next week's class, just to be really honest, next week's class is a bit tricky and harder. And we talk about 2 chapters. So I really, really want you to spend a little time to, yeah, it is harder. So I really want you to spend a little time to just quickly go over chapter 5 and 6. You don't need to fully understand everything, but just get familiar with the concept. right? Get familiar with the words that I'm going to use. Like I'm going to talk about z-score. I'm going to talk about the distribution, probability distribution, right? That's for next week. So I don't want you to get lost. So the best way to prepare and get the full value out of my lecture is to quickly go over and get familiar with the words and the concepts. And then we will go to details and we will do exercise examples together in class. So you get the best value. That's my strong recommendation. Try to read chapter 5 and 6 before next week. That's all I got. Any questions? No question? We're good? Okay, very nice. Thank you, everyone. Enjoy the weekend then.